and I am currently working as a senior ML engineer at Hair Technology. And mainly, I've been working on graph neural network. And past, I had worked on TCS Research Innovation Lab on reinforcement learning and portfolio optimization. So, for this talk, I wanted to talk about the reinforcement learning, especially a particular algorithm of reinforcement learning, which is called deep Q network. And I will just introduce some basic terminology related to the reinforcement learning. And as we progress through the session, I will also explain like how the this Q learning works, and obviously I'll try to give some examples on uh, how these things can be implemented easily by taking the real life analogy. So bear with me, and I'm just going to explain everything very step by step, and I think it is going to give you a good insight about the things. So if I talk about the reinforcement learning, so like what is the reinforcement learning? So generally we know that key reinforcement learning is the uh, branch of machine learning. Actually, branch of machine learning is divided into two parts. Actually, there is supervised learning and there is unsupervised learning, and then the third is the reinforcement learning. So this reinforcement learning is the area of machine learning which concerned with how intelligent agents should take action. So there are agents and it's all about taking action by interacting regularly with the environment and trying to maximize the cumulative reward. So like we will discuss like what this action means, what this environment means, what is the reward, and how the agent actually learns all these things. So the basic idea behind the reinforcement learning is that it is all about the reward. So the agent has a reward in his mind, and the trying to maximize the reward by taking the different actions according to the state given by the environment. So terminology basic thing is that the reinforcement learning just the area of ML, and it's all about taking intelligent action. Now the second thing is that the RL is learning what to do. It's about what to do given a situation. So there will be a situation given and it's about what to do and a set of possible action. So it's not like there can be random action. So there will be a set of action, and on those set of action, the agent has to choose a particular action, and on the basis of the action the agent will be given a reward. So reward can be a positive reward or a reward can be a negative reward. So if I talk about this, the figure that you are actually looking, so just simply just stand at any time point t. What we do is we give a state st to the agent. So environment is responsible for giving the agent and state st. So like if in as a perspective and understanding, these things are agent environment, but these are all the codes. So when you just train the models, these are all the codes that you need to write. The agent is a simple code, the environment is also a code, and the reward is a number, state is a some row, some data that you are trying to give to the agent. So these are all the practical thing. Just in the terms of reinforcement learning, we talk in the terms of agent, environment, reward, action. So at any time point t, the environment gives a state st to the agent, and the agent take an action at. Okay, and based on the action at, whatever the action that has been taken by the agent for the state st, there is a reward rt. So there is a reward rt, and for that particular thing, agent means this particular reward that we give to the agent, that become actually the basis of learning, like how the agent is learning. So I will just explain these things in detail also, but this is just the overview. And then this again, this process is keep repeated. Like again at time point t plus 1 we give st plus 1, at time t plus 2 we give st plus 2, and the same thing goes on. But I will see like how these things are actually working, and the how this agent also learns along the way. Okay, so if we just move ahead, so there are some elements of reinforcement learning. So elements means like whenever we try to train our machine learning algorithms, we have algorithm, we try to optimize it, something like that we do. So there are also a element of some elements of reinforcement learning. So these elements of reinforcement learning are like the agent is something that we keep hearing again and again, and also the environment. So these agent and environment are the two entity of the reinforcement learning that is always going to be there. Apart from this things, there are also many more things possible. So first thing is called a policy. So what is policy, I will discuss in detail. Then a reward, a value function, and the model of the environment. So obviously this four thing is optional, and now these things is not more common. These things used to be common in the early days of the reinforcement learning, but these first three things are very important. And apart from agent and environment, there should be a policy, a reward, and a value function. So I'll discuss like what do you mean by policy, what do you mean by reward, and what do you mean by the value function. But apart from the agent and environment, there is always going to policy, reward, and the value function. So just talking about these all things in very detail. So a policy define the way agent behaves in a given time. Like let's say you are training an agent to, let's say, take some particular action. So means it's all about the behavior of the policies, all about the behavior of the agent, and this is what the agent is trying to learn in the long run. So it's not like the policy of the agent in the beginning of the training RL is not mature. So that is what we want to train. We want to learn the policy of the agent. So like it's all about the newborn child. So initially when means a child is small, he does not know to walk or to how to eat, how to talk. But as the time progress, the child actually learn all those things. Same goes with agent also. This policy of doing the things, whatever task you want to do using this reinforcement learning, this is what the policy is going to be learned by the agent. Okay. So the policy defines the way the agent behaves in a given time. A policy is a mapping from the state of the action to the state of the environment to the action. So let's say there are some state of the action. So these are S1, S2, and this kind of state is there. So this is a state of a state. Okay. And there is some action. So maybe there are three action. Okay. A1, A2, A3. So it's all about, let's say, you are trying to give image to the agent and what asking whether it is a cat or dog or maybe something other, maybe a house. Okay, so these are the action possible. So maybe we can denote a cat by A1, dog by A2, and a house by A3. So we want our agent to learn the classification of image. So that can be a possible task that you want to do using the RL. Other kind of thing, maybe let's say you are training a robot and you are training the robot to walk. So the action can be like move forward, so move forward, then move backward, then move right, move left, something like that can be there. Okay, so that's depend all on the context of the problem that you're trying to do. So let's say there are three action. So whenever we are going to give in a state S1, let's say at time point T1, T is equal to 1, we are giving a state S1 to the agent. So the agent will take the state S1 and it will give an action. So this is what means how the agent is actually giving you some action. This is based on the policy. And the thing is that as you keep progressing through the RL, the actually policy is being modified. So a policy can be a simple function or a lookup table in the simplest case. So these used to be the very early days of reinforcement learning, where like a it's all about the mapping. So there used to be a table, and obviously according to this state what action you need to take, according to this state what action do you need to take. So these are the deterministic thing, but rarely this kind of thing happen in the real world, or it may involve a complex function computation. So like in the real sense, we actually train some function, try to learn some function, which if we given some state st, will try to predict or take some action at. Okay, so this thing is what is a policy for us going to be in the RL case. The policy is the core of the agent learned. So if you trying to train a RL algorithm, then whatever the agent learn, it's all depend upon the policy. So at any time point you are taking the action and then you are trying to update the policy. So this is what our core learning is going to be. So like in a different RL algorithms, different types of, there are different ways to define the policy, there are different way to learn the policy. But yeah, this is what we are trying to learn. Once we learn the policy, the work of agent is done, and then we can utilize this policy. It's also called the brain of the agent. Okay, brain of the agent. So this is what we utilize in the long run. So in general, a policy may be stochastic, specifying probability for each action. So this is what in general happens, the policy is exactly a stochastic. It's not like a some deterministic table or something like that. Whenever you give some action state st, this is going to give like for A1, A2, A3, what is the probability of going to be A1, what is the probability for A2, and what is the probability for A2, something like that it is going to give. And based on like obviously we set action which is going to be the highest of the highest probability, we take that particular action. So this is what in general the policy is. But apart from policy, there is something called reward, which actually is primarily basis for altering the policy. So if we talk about the reward, so a reward defines the goal of the reinforcement learning problem. So like let's say there is a agent, okay, and you want agent to train for some particular task. So what we usually do, if the agent try to learn the means if agent perform the task correctly, we give it a positive reward. So positive reward signal the agent that this is a good thing and you have to keep taking action like this. And if let's say agent makes a mistake, we try to give it a negative reward. A negative reward means positive reward means let's say we are giving +1, and negative reward means let's say minus 0.5. So this obviously reward is a scalar number, it's not a vector, it's just a number, a positive number, it can be negative number based on whatever the action the agent is taking. So whenever agent is we are trying to give the positive reward for particular action, the agent will try to take that action again and again. Like let's say we are trying to teach a child to learn something. Let's say we're trying the child to learn maths. So if he solve the maths correctly, we give up let's say a chocolate or maybe something else. And if the child solves the math incorrectly, we just don't give him a chocolate. So that's a negative reward in that case. So whatever the child will do, the child will try to solve as much math as correct to try to gain more and more chocolate. So something like that. So RL is all about like how we humans learn in the real environment. But the thing is that here we have codes, we have agents, everything is a code, and we're trying to train the agent to learn that way. But yeah, if you just try to understand, or just try to understand in the terms of what we learn as a how we learn as a human. So at each time step, the action of the agent results on a reward. So this is what I was talking about. Whatever the action the agent is taking, it will give some reward. So at any time point, if the state is ST, take action AT is taken, then on based of that, a reward RT will be given to the agent. So this is repeated at each time step. This is just the basic of the RL. The agent's final objective is to maximize the total reward it receive. So it's like like let's say there are n number of actions taken. So let's say the reward is maybe 105, just a number. And maybe at next particular time step in the reward is maybe 100. So what the agent is trying to learn, whenever we're trying to teach train the RL, the agent final objective is to maximize the total reward. So how it will maximize total reward, it will try to take the positive action again and again. So you might start thinking that if this is so simple, like the agent can take the positive action, means the action that is giving a lot of reward. Let's say A1, A2, and A3 are there. So let's say A1 is giving a lot of reward, maybe a lot of reward. What we can say that expected reward maybe let's say 0.9, and same less for all these things. So agent will try to take action A1 and A1 again, try to maximize its reward. So that's how a problem arises while trading the agent. It's called the greedy, means taking the greedy action. But we'll talk about it, how we solve the greedy action. So but what the most important thing is that the agent always try to maximize the total reward. Now the third thing is that is the reward thus distinguishes between the good and the bad actions. So if you are giving it the positive reward, it means that you are taking the good action, and if you are taking the negative reward, it means you are trying to you are taking the bad action. Obviously you can, it's like penalizing the agent. Penalizing means you are just punishing the agent for taking the bad action. The second aspect of this you can think of is that let's say if there are two three action, what you can do is maybe you are trying to give a variety of rewards. So like there has been many research paper based on the reward itself, like how to actually construct the reward function. So obviously reward function also can be a stochastic function, and also can be a deterministic function also, maybe some simple number also. So like let's say we just define a reward just by you can say that maybe a standard normal distribution. So it's a standard normal distribution, and whatever you are trying to give means whatever the action the particular agent is taking, just to feed it into the standard normal distribution and just take it a reward. Maybe at any particular time what you are doing, just generating a number from -1 to 1 and giving the agent as a reward. So this is just like the uniform distribution. So anything you can do this, but yeah, in particular we just take a number like +1 for positive action, minus 0.5 for negative action, or something like that. Maybe +10 for some actions, so +5 for some second immediate action, +3 plus 3 for some immediate third type of action, -1 for taking altogether negative action. It's all about the problem. Anyway, you can engineer the type of reward function that you want to do. But yeah, the type of reward function actually decide how the agent is going to learn, and this is actually the primarily basis for altering the policy. So whenever the agent takes a positive reward, it just try to update its weight, or you can say that it try to update its function such that it has to take these particular things again and again. And if it's take a negative function, it just keep in mind that you just don't try to make this type of mistake. So this is the type of intuition I'm talking about. But yeah, These are all happening in terms of math and code, and obviously if it's a neural network, then adjusting the weight and biases, all those things. Okay, so apart from policy, agent, environment, reward, the next thing is the value function. So a reward signal indicates good action in an immediate sense. So this is what I was talking about. If let's say this is the agent and it takes an action 80. Okay, so this is just the immediate action. Just this is the what the action has been taken immediately. So let's say if 80 is equal to what the we expected, then we give it a positive reward. If 80 is not equal to what we had expected, then it's give it a negative reward. Okay, something like that. But what in the long run means, obviously we are not just interested in the immediate step. Our objective is to train the agent for some task, for taking the some long. It's not like just take the step once one again and again, this is what we want to do. We just want to train the agent to take some task again and again, and just keep doing that particular thing. So it means that for that particular case, there is a called something called value function. And value function define what is good in the long run. It's not about the obviously reward for the short term, or value function in the long run. It's all about us. Let's say we are particularly doing some kind of job. Okay, so obviously salary that you get, it's what of the immediate action, monthly salary that you get. But obviously there should be long term satisfaction. So let's say you are trying to do this job so that you can uh, you are thinking about next 25 to 25 years of the planning related to this particular. This is what we mean by the long run. Just you are trying to do this particular thing for 20 to 25 years. But yeah, many time people just do some particular job for maybe 1.5 years, and then particularly they change the job to get to the some point where they can enjoy the particular job. They do what they want to do. So all it's all about the long term vision. So this is about the value function. So value function defines what is good in the long run. The value of the state is totally aggregated the number of rewards that agent can expect to get in the future if it starts from the state. So it means that let's say at it's about time point t. So it means that the agent can expect to get in the future. So it means that let's say the agent start from that particular time point t and get towards the end of the episode, end of the learning. Okay, so the value function means that this is what the expected reward that the agent can get if it start from that particular state and keep learning the same way. So this is what the value function means. To understand the value function, just you can understand this with the real analogy also. So like a value function means that the time point at which we are at present, and it decides like what is we are going to do in if we just keep this particular thing and start moving from that particular point. Okay, so it's not a complex thing. If I just show you the formula like how this particular thing is calculated. So value indicates the long term desirability. Obviously I talk about this about the long term run. And even if a state might yield a low immediate reward, it can have a still high value because it regularly follow the other state that yields higher reward. So like let's say that a particular action a1 has a lower value function, sorry, lower reward. So it may maybe minus negative reward at any time point t, or it has some lower reward. But it say that it's not like that a1 is always going to give you the lower reward. If it may happen that just you try to do something else in the future, and you can obviously try to maximize those reward also. So that kind of thing can be possible. So if I talk about the value function or something more. So the agent always seek action that bring a state of the highest value, not the highest reward. Okay, so it's like we have to train the agent for the future purpose. It's not like for the all the immediate reward. Okay, and this we will just like see how we do this when we try to train the agent. Okay, and these state will lead to the action that on the highest amount of reward over the long run. So this is all about the value function. It's all about the whatever you want to do in the long run. It's not about the immediate step or immediate reward. So one question that is obviously popular in the ML is that how then determine the value and the rewards, like how determine the value function, how we determine the reward. So the first thing is that rewards are directly given by the environment, but values have been constantly estimated. So like I told you, just maybe the reward can be +5 or -1 as a negative reward. So these are the constantly given by the environment whenever the agent takes some particular action. Okay, but the value function is exactly estimated. So there are many estimation method. One can be obviously take the average, but yeah, this is what how the value function is estimated from the observation that agent make at each interaction. So at, let's say, at time at till time point t, so for starting from 1 to time point t, agent must have taken some reward, some action, then some reward, some action, some reward, something like that. So based on all these observation, we try to estimate the value function value for the each of the particular action. So these are the estimated value for the each particular action. Okay, this will make the method of estimating value efficiently the most important component of reinforcement learning. So obviously, apart from policy, like what are the method that you're trying to use to estimate the value function is also the important part of the reinforcement learning. And many different algorithms are based on by taking the different value function, different taking a different way to estimate the value function, something like that. So it all depends on the algorithm. So at this time point we have just learned a lot of things about, like what is the RL, what is the agent, what is the environment, what is the policy, action, and then value function. But yeah, there are some more things that I want to explain. So obviously we know about what is the agent, the action, what is the state. So a state, like a state is something, it's about the data. So like this is a data. So this particular piece of data can be a state. Okay, so it's all about the problem. Whenever you're trying to formulate any problem into a reinforcement problem, you have to like identify what is your state, what is the action that you want to take, and what is the reward. Like I explained in the terms of, let's say we're trying to train the agent for the classification. For that particular or type, the number of classes are the action. Let's say there are three classes, so these are the action. Whatever the data that we're trying to give, that is a particular state. So any time point t, a particular row r1 can be a state s1. Okay, and reward, maybe if the agent try to classify the class correctly, you can give the positive reward. So something like that can be there. Obviously it's depend upon the task that you're trying to do. But yeah, I talked about the greedy action. So greedy action means that, okay, so let me just explain the greedy action. So I told you that whenever we maintain estimate of the action value, let's say this is action A1, this is action A2, and this is action A3, and let's say at this particular time point, the action value may be, let's say 1.5, maybe 2.5, and minus 0.3. Anything can be there. Then at any time step, there is at least one action whose estimated value is greatest. These are called the greedy actions. So like what the agent try to do, agent try to take that particular action which is actually have highest estimated reward. So let's say this particular time point A2 is the that particular action which has the highest estimated reward. So 2.5. So agent will try to take action A2 again and again, because previously it has seen that whatever whenever I take the action A2, the amount of reward that I've achieved is greatest. So it again try to take A2, 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 A2. So this is, this is called a greedy action. It's like, like in life, let's say you are doing something and you are getting some big amount of whatever you can say a reward, maybe money or something like that. You try to do thing again and again, but does not mean that this particular thing is going to give you other aspect of life also. It does not mean that it is going to give you happiness also, it is going to give you satisfaction also. So for that, maybe you have to choose some particular other action and keep moving with that. And maybe for that, like uh, that can be beneficial for you. It's not about the immediate reward. So that is what is called a greedy action. So like there is a term called exploration dilemma. But yeah, just let me tell you like what is the exploration and what is the exploitation. So whenever we choose any of these actions, we say that we are exploiting our current knowledge. So whenever we're trying to take the greedy action, so if we're trying to take the greedy action again and again, okay, so it means that you are just exploiting the current knowledge. Exploiting means just you are not trying to explore, you're just trying to exploit your current knowledge. But yeah, let's say apart from exploiting the intelligence, what you do is that you just take any of the non-greedy action. Means apart from A2, A1 and A3 are the actions which are having less estimated values. So what we can do, maybe randomly we try to take action A1 or A3. So in that case we say that we are exploring. Like this is also happen in the real life also. Some people, let's say they are doing task one, they again start to do task two. After that they maybe start to do task three, task four, something like that. So people may say that okay, he's trying to explore like what does he like. Maybe he like task three, or maybe it like some other task or something like that. Okay, so this is all about exploring and exploitation. So exploitation means you are trying to take the greedy actions again and again, and exploration means you are trying to take the actions which is not a greedy action randomly. Or maybe just it's all about, like just trying to explore something, that try to explore like which action can be better in the future. not right now. So exploitation is desirable for the next step. Obviously, if you take the highest reward state, you are going to get the maximum reward in the next step. But exploration may produce the greater total reward in the long run. So this is what I want to tell. Maybe it turns out that A3 is the that particular action which takes the highest reward, something like that. So it is important for agent to see or take all these action again and again, not to be biased towards any one action. So this is what people actually do. And like in terms of training ml algorithms, the rl algorithms, people generally do different types of things. Maybe like if they are trying to initialize the weight of this particular value function initially, they may try to start by giving same number to each of the particular action. Maybe sometime they flip the value function for other each and other actions. So there are many ways to do this, but yeah, there is something called epsilon. Obviously, this is something called epsilon greedy action that I will just discuss what that particular thing means. So goal, like whenever we're trying to train the agent to, it's obviously its overall agenda is to maximize the cumulative reward. So this is what we call the goal of the agent. So in RL, purpose or goal of the agent is to formalize in terms of a specific signal. This means reward only, called the reward, passing from the environment to the agent. So I discussed these things with you all, and the agent's goal is to maximize the total reward it receives. So whatever actions you are taking, the agent only goal is to maximize the reward. uh, Maximizing not the immediate reward but the cumulative reward. So cumulative reward means whatever the reward that you are trying to take starting from action, once starting a time point t is equal to 1 to t is equal to n. So it's about all the cumulative reward that we are talking about, not about just a single reward. The reward signal is our way of communicating the agent what we want to achieve, not how we want to want to it achieved. Okay, so like let's say it's all about like let's say you are trying to give the agent a positive reward for taking some particular doing some particular task there. It's clear that you want our agent to classify, let's say it's about the classification, classify all the data point correctly. However the agent want to do it, just let them learn. And how did that does that actually happen? That actually happens, like whenever try to train the RL algorithm, the particular things happen because we are trying to adjust the weights by different things. So that is not the our objective, or objective is the what we want to achieve, and that is what we try to do in the reward signal. So this is all about the formulating any problem into RL problem, and that is what is going to help you. So uh, we are again at the action value method. So let me just talk about the action value methods, like how do we estimate this particular method. So it includes the method of estimating the values of the action for using the estimate by making action selection decision. So I told you, like whenever we take some action, we have to means like let's say there are three action, we have to decide which action to select. So first of all, let's say like how action value method is like what are the action value method to estimate the action value. So like for particular action A, we denote its actual action value by q star A. Okay, so this is what the true value of action A is denoted by, and the estimated value after t plays is qta. So qta means till time point t. Means if the starting from time point t is equal to 1 to time point t, it means that the action value is qta. Okay, and the original, obviously we don't know the original value, but yeah, we want to estimate the original like this particular action value, which is denoted by the q star A. So one natural way, like to take the average. So let's say at time point till time point t is equal to tn, we may like we may just aggregate the all the reward function, all the reward that has been taken against each particular action, and just take the average. So let's say for any action A, what we can do is that sum of the rewards when 8 taken prior to t and number of 10 times 8 taken prior to t. It means that let's say t is equal to 10. Okay, and let's say for there are three action a1 a2 a3, and let's say for three times a1 is taken, and let's say if the a1 is taken, then the sum of reward maybe, let's say we're trying to give for taking action a1, if we're trying to give zero point 0.5, so it means that 5 5 5 15 by 3. So it means that the total cumulative reward is 5 for at time point t is equal to 10. So this is how we can generally do this particular thing. But this is not the only method. There are also more complex method that people use to take the action value method. This is a simple way I wanted to explain. Okay, so the action selection rules tells that ki, like which of the action do you want to take. So like I obviously explained in the beginning also, we always take that particular action for which this particular action value is the greatest. So let's say at any time point t, QTA for A1 is equal to, let's say, uh, zero point 0.5, QTA for A2 is, let's say, is equal to 0.7, and let's say QTA, it can be any number, it's not between 1 and 0 and 1, something like that, is, let's say, 1.5. It means that we are trying to take action this particular thing because uh, this is what the action selection rule means. We are always trying to take the action with the greatest action value. And that is why we also, like told you, ki we have we are always trying to take the greedy action. So this is why the greedy action is there, because we always try to take the action for which the action value is the greatest. But at this point of time, to handle, like, how do we actually handle the greedy approach, how do we handle this particular thing? Because either we'll keep exploiting the same action again and again. So for taking into that particular consideration, we actually used epsilon greedy method. So epsilon greedy method tells that ki alternative approach to behave is that, means either there is a way, like either you can behave greedily, or maybe there is some way that you can control this particular thing. So apart from behaving greedily most of the time, what you need to do, with some probability epsilon, select an action at random. Okay, so let's say we choose epsilon is equal to 0.1. Okay, so it's like 10% of time we are taking a random action, and 90% of the times we are taking the action from the this particular action value pair. Like obviously, if the q1 is greatest, sorry, a1, for the a1 the q value is greatest, we take that particular action. A2 is greatest, we choose that action, something like that. So it's called the epsilon greedy method. Okay, now what we generally do is that we just don't keep the epsilon fixed in the while training. So what people generally do is that, let's say if we're training 1,000 step, so maybe we will keep epsilon high in the beginning, so we will allow our agent to explore more and more in the beginning. And as the, let's say, number of steps trying to approach 1,000, we try to decrease the epsilon. So maybe we can keep epsilon 0.0000001 whenever after training for some time. It means that we are going to uh, let our agent explore just 0.01% of the time. So this is a good approach, because initially the agent needs to explore much, but as the training proceed, it's just need to converge at some particular time point, just not explore much, to try to take the greedy action. That is good, that is fine, because it has explored a lot starting from the beginning. So theoretically, the theoretical result shows that if we just take the number of actions again and again, then if each action will be sampled infinitely, and if we just sample each of the action infinitely, then it is true that our the QTA is going to converge to the original Q star A. So this is what a theoretical result motivates us to take this particular thing, do this particular thing. So in an infinite case, obviously if the each of the sample is getting shortlisted a lot of times, an infinite number of times, we are we are anyhow going to converge to the original value. So it means that these are just the asymptotic assumptions, that just it's not like that it can be the case for the real training also. But yeah, this is the theoretical result that help us to do this particular thing. Again, a more general keyword that I wanted to discuss is the Markov decision process. So whatever the problem you see in the RL, that is actually need to be converted in the Markov decision process. So like this is related to the Markov property. So Markov property says that the state ST is a Markov if and only if means it means that the current state depends only on the immediate previous state, and not on the all the possible state. So immediate previous step means the action at means whatever we're trying to do at time point t plus one, that may depend upon the time t. Okay, so Markov decision process means that we're trying to construct our whatever the problem that we're trying to teach or trying to learn using RL, using using the this particular type of things. Like let's say at any time point t, you are wake up, so there is some probability of you to code and debug. So let's say this is 0.5. Okay, let's say this is just an assumptions. At that particular time point, if a particular guy is wake up and code, we are giving r is equal to -3. Just it's a reward. Okay, and then if he may try to sleep at that particular time, he may also try to do some other work like deploying the model. He also try to take the nap but not sleep. So for that particular kind of thing, we are giving some reward and some particular thing. So it's all about like the flow chart, like how do we want our what you can say, our RL means whatever the problem you are trying to solve, you are trying to just convert a flow, overall flow of the how the actions will be taken, how the state will be taking transition from one state to another, something like that. So it's all about the Markov decision process. So like the figure that I showed you initially, this particular thing, this is something like that also, like any time point t. Okay, I just need to go in the beginning. So like any time point t, you are taking the x and st, then getting the x, taking an state st, then getting an x and at, then getting a reward rt, then again sending st plus one. So this is just like the Markov process, and like a any RL problem can be formulated in the Markov decision process. So that is the general assumptions, and based on that, there are a lot of theories related to like how do we estimate all those things and are there. So as I promised to means teach something about a deep Q learning. So let's now we have some background in the RL. So now we can just move to the deep Q learning and see like how this deep Q learning algorithm works. Okay. So for understanding the deep Q learning, the main ways, and like the main particular thing to understand is the Q learning. What is the Q learning? So in early days when there was not a lot of computational power, the Q learning was popular. So Q learning algorithm is based on the Q table. So like let's say a particular robot is there which is trying to take an action left or right or up or down. Okay, maybe you're trying to you can say that key make some game or something like that, or something like that can be there. Okay, so let's say a particular state at any particular time point, what we used to do is that the Q table calculates the maximum expected future reward for each action at each state. So like at this particular state, maybe this is a particular action that which have the maximum expected future reward. Now at this is equal to time point t is equal to 1, at time point t is equal to 2, this may be the uh, action which have the maximum value reward, and something like that can be always be there. Okay, so something that can always be there, and obviously we just try to maintain a queue table. But obviously these things changes when let's say you have a lot of data and the problem is very very complex. It's we cannot do using the table. So what we do, we try to learn a function, and function means this particular function, whenever you try to give some particular state st, it will just output a action at. Okay, so this is what the general idea behind the deep q learning, but I will see like how this q learning algorithm works. So Q learning, it can be proven that the given sufficient training under epsilon soft policy, the algorithm converges with probability 1 to the closure approximation of the action value function for an arbitrary target policy. It just means that this particular algorithm theoretically is good. Okay, so Q learning learns the optimal policy even when the actions are selected according to a more exploratory or random policy. So if you are just trying to maintain everything in table, it means that at each time point we're trying to update the table, and whatever the action we take over, obviously in the longer run the things is going to be correct theoretically. So like the simple algorithm just is something like that. So let me just do that. So first of all, what you need to do, you need to initialize QSA. So you can understand what is QSA. So QSA means for any state is like for any state is what is the estimated value for taking an action a. Okay, so just obviously in the beginning we initialize this particular thing arbitrarily. So let's say there are three actions, so we can initialize using the any three numbers, and at each step what we do, initialize is and repeat each this process again and again. So like there's something called episode means let's say we want to train our agent for 1,000 episode. Okay, so episode means ki we will keep training the agent as it is episode unless it try to finish categorizing all the data, or maybe it makes some mistake. So there is something called terminating the step. I think I know that these are all the terms related to the practical of the RL, like how the RL is being trained. But yeah, terminating episode means there is some criteria actually decided by the experimented, like how he try to terminate the episode. An episode means that he is just starting a time with time point t equal to 0 and taking at each action, each state again and again, and then reaching at time point t is equal to n. But yeah, episode can be terminated in between the training also, and there is some criteria for that. So whatever we trying to do, obviously, for learning the epsilon greedy method, what we do, we choose action A from the S using policy derived from QA. Okay, so like whatever the maximum action value pair is, that we take the particular action. Obviously, this is we need to do is using epsilon greedy, because which, let's say epsilon equals 0.1, then 10% of the time we need to also take the random decision. And whenever we take action A, we observe the reward, like what is going to be the reward for the action A, and what is the next state, which is S dash. And what we try to do, we again update that particular QSA value using this particular formula. So this particular formula has some significance, but let's not talk about it right now. So, and then move from state S to S dash, then again keep repeating the same action, same thing. Okay, so this episode is actually terminated when S is a terminal episode. Terminal means the last episode, or maybe you have some other criteria for terminating also, it can be there. So at each time point, what you need to do, take some action, update, take some state, take an action based on that state, observe the reward and next state, and obviously update this particular value. Okay, and this is where we are trying to take the maximum whatever the alpha is going to be maximum for. Okay, so alpha is called a learning rate. Okay, this particular alpha is called a learning rate, and it decide like at what degree this is alpha. Gamma is called discount factor, and max alpha is the maximum reward that is attainable at the state following the current one. So this is all about the taking the optimal action at each time point. And obviously, if we just talk, this particular alpha is decide like how fast the particular thing is learning. Gamma is called discount factor. This has some other definition also. We'll just keep it for some other time. So overall, the algorithm is just simply that: initialize queue. Queue means for all the state, initialize a queue. Okay. Choose action from queue. Obviously, that's what we need to do. Perform that action. Action means get some reward, and update the queue. And this keep this particular thing again and again. So this is what I was talking about. This particular thing. We the new queue value is updated according to this formula. The old value plus a learning rate, then whatever the reward that has taken for that particular state by taking the action 80, discount factor, these are all pre-decided. Maybe discount factor is equal to 0.5, you want to set alpha is equal to 0.01, these are all decided. And then whatever the max action that you have taken according to the for the state, this particular means whatever the QST plus 1 A is there, just take that particular value and minus the old value. So this is called a TD error. These are all the, I think, can be explained a lot, like hours of lectures can be done based on this TD error and all this formula. But this is the formula on which we update our old Q value. So this is just about the Q table, Q learning. It's what about the deep Q learning? So deep Q learning, instead of using the key table, we use a neural network that takes a state and approximate the Q value. So I told na in Q table, what you need to do, just maintain a table, just like this, maintain a table. And whatever the state that you are trying to take, just take the particular action based on the table. But obviously this is just a very long process, because let's say there are a lot of state, lot of state, a thousand millions, then that particular table is impractical. In fact, neural network approach is better. And what a neural network approach do, so let's say this is a neural network. So whenever we give some state, okay, so it will just output a value. Let's say there are three values, so maybe it will give some q values. Or maybe if we're trying to take some action, it will also give the probabilities, like what is the probability of taking this action. This all depend on the context. So neural network takes a state and approximate the key values for each action based on that particular state. So instead of using the table, now we are using the neural network. So what is the significance of neural network? Neural network just act like a function. Let's say f star, and whenever you give st, it gives the what you can say. Now for each action, let's say there are three action a1, a2, a3. So for each action, it will give you the value. Like this is the key value for action a1, this is the key value for action a2, and something like that. It will give you. So if we're trying to learn the algorithm of the deep Q learnings, there is something called replay memory. So like let me explain what is the replay memory. So let's say in the replay memory, what we do, we take some state, then we take some action, we observe the reward RT, and then we take the next action. Okay, next state, and we do this particular time and store this particular thing in the memory. We again keep the state st, take the choose the action 80, then take the action whatever the reward RT is there, and just store this tuple, this particular thing again and again in the memory. Okay, again and again in the memory. This is called the action replay memory. Okay, and we use these instances to train our deep queue network. So what we do, let's say for episode from 1 to m, obviously we now have an action replay memory and action value queue with a random weight. So I told you na, ki these particular things are if in the neural network you just try to initialize it using a random weight, and then we'll try to update it. So for t is equal to 1 uh, and the capital T, what you need to do with probability epsilon, this is called epsilon grady, whatever we are talking about. So take a random action 80, otherwise select 80 from the max of the this particular thing. Okay, so execute action 80. So like you can may ask like in the neural network what you need to do. If the in the neural network, if you just feed the particular state st, it will give the reward. Sorry, it will give the action 80. Okay, and you may ask that how this particular thing is working. So simply if you just feed the st to the neural network, these all weights, whatever the random weights in the initially, this will just try to give the some number, and then after calculating this particular thing, it will give the action 80, obviously by choosing the maximum of the q value from the action. So what you need to do, that execute action 80 and observe what is the reward and store this particular transition. Like I told key, you have to store this particular transition. Okay, and now move to the next state. And then what you need to do, whenever you have stored this particular thing in the sample replay memory, you have to take these particular things and update your weight. So that is what it is saying, is sample random mini batch of transition. Let's say we're sampling, let's say n is equal to 100 or something like that from this particular thing, and using this particular thing to update your neural network. Or we can say that you just take the action and then update the weights of the neural network. So now we just change this particular thing to yj is equal to rj if the is a terminal state. If it's not terminal state, we just using this formula, and then we just take gradient step on this particular thing. So yj, like yj is what we are trying to state the action value. Sorry, the this particular uh, QTA. Okay, so this is what is being predicted by the numbers, and this is what is basically being observed. So we just try to minimize this particular error to arrive at that particular point where at the training this particular thing again and again, this algorithm will learn to predict the your QTA. So in short, the thing is again here, just we initialize queue, choose action from queue, but these are choosing from the neural network. It's not like the table. And then perform action, whatever the action is being taken, and then just store this particular thing in the memory, and then take a, what you can say, just take a sample of the state from that particular thing, and then update your neural network, and then keep updating this particular thing. I know this deep queue learning is more, I think it's more good for when you are trying to train the network. But yeah, in the theoretically, it just like just take the action 80. Obviously, if epsilon is equal to 0.1, just take that particular thing 10% of the time, then keep repeating this particular thing, store the transition, and just keep updating the neural network. Now, based on this particular thing, there can be a variety of deep Q learning. So there's something called SARSA. Okay, so this is state action reward state action. So like there are different terminology related to the RL also, like off policy, on policy, model based, model free algorithm. So obviously you have to means they're depending upon like how do you want to train the network. So obviously there are some variety of Q learning where you don't construct any replay memory. What we do, we just take this particular thing again and again. So there's no need to store this particular thing. Whatever the action you are state you are taking, just update your neural network in the next step and just try to repeat this whole thing again and again. So obviously all these particular things depend upon the how do you want to perform. So that particular algorithm is called SARSA. It's an on policy algorithm. But yeah, this deep Q learning is off policy algorithm, and I think this particular uh, obviously there is different ways, like how the SARSA will learn how this particular uh, Q learning will work. But yeah, this is how this deep Q learning works. Just taking the action, random action, add taking some some epsilon, then obviously observed action and reward, and then store this particular transition, take some particular batch of this particular algorithm, and then keep updating all those things again and again. So this is how we are trying to learn the Q function from the neural network. So this is how we can do this particular kind of thing. So it's all about from my side about the basic of RL and some basic understanding of Q and deep Q learning. So thank you everyone for joining here.